Now that we've graphed using a table, I'm going to show you how to graph using transformations. So we're going to revisit the parent function, again y equals the square root of x. And one thing I want you to know is that to get to the next point, we are always rising by 1 unit. So notice we're going up 1, up 1, up 1. To get to the next point, we go up 1. But when we go over, we're going over 1, over 3, over 5. And so notice there's this odd pattern that we saw with our parabolas. Remember our parabolas, we went up 1, up 3, up 5, and we always went over 1. Well, remember I told you that a parabola, a quadratic, and a square root function are inverses. So what that means is instead of going up 1, up 3, up 5, we're going over 1, over 3, over 5. And we're just going to go up 1. So notice again, we're adding 1 here, plus 1, plus 1, plus 1. But then down here, we're adding 1, adding 3, and adding 5. So every parabola, or sorry, not parabola, but every square root function has this pattern. So this odd pattern that we did see with our parabolas says that we're going to go up 1, over 1, up 1, over 3, and up 1 over 5. And notice that this is the vertical. This right here is the vertical. It's always going to be whatever times a. So it's going to be 1 times a. So if we have a stretch, the vertical is affected. If we have a shrink, the vertical is affected. And then our odd pattern here, this over 5, over 1, over 3, over 5 will always stay the same. This is the horizontal. So this will never change. You will always go over 1, over 3, over 5, but how much you go up will change based on the function. So starting here, remember our transformations, y equals a times the absolute value of x minus h plus k. So starting with our a, we know, and we saw this with our tables, that when a is negative, we have a reflection. So a reflection when a is negative. We know that we have a vertical stretch if the absolute value of a is greater than 1. And notice it's absolute value because the negative is the reflection, the number is the stretch. We have a vertical shrink when the absolute value of a is less than 1. So meaning the value of a is between 0 and 1. 1/2, 1/3, 5/6, 0.2, anything like that is going to create a shrink. And again, this is going to affect the odd pattern, the up 1, up 1, up 1. So if the a was 2, you'd go up 2. If the a was 1/2, you'd go up 1/2. If the a was -5, you would go down 5. Okay, so it's only affecting the up part. Okay, now one thing to remember on here is that if a, since we did horizontal that, let's do orange. So if a equals 1, okay, this is just a normal parent. So this means no stretch or shrink. Okay, so remember that if it equals 1, there's no stretch or shrink. If it's more than 1, it's a stretch. If it's less than 1, it's a shrink. Now, another reminder is that we have our hips and knees. So remember our H is going to be our horizontal translation. Okay, and this is our hips. So remember, our hips means opposite. Whereas our K is our vertical translation, and this is our knees, which are normal. Okay, so normal knees, it doesn't change. You keep the whatever value it is. Hips opposite. So if H is negative, it's really going to the right, a positive value. If H is positive, so if it's X plus H, it's going to the left, and it's going to be a negative value. Okay, and what's important about our HK is that our HK serves as our starting point. So our hips and knees, this HK, is the starting point of the graph, and it would also help you start your table. Okay, so knowing these transformations can actually make using a table easier because it tells you what value to start. So HK tells you where to start your table, tells you where to start your graph. It's also important because it will help you with your domain and range. So it actually gives your value for your domain and range. So you can find the domain and range without actually graphing. Okay, so the HK gives your domain and range, it gives you your starting point of the table or the graph. So to graph using our transformations, okay, so let's start with number 5 here. We're going to have y equals 2 times the square root of x plus 4, and then minus 1. So one thing you are going to want to be careful of is to make sure your square root only goes over the x plus 4, and the minus 1 is on the outside of the radical. These are little things you got to pay attention to. And this particular function is a lot more difficult than the ones we just did, and this would be more challenging with a table. However, if we do transformations, it's quite simple. The first thing you do is you find your starting point. So our starting point here is going to be our H and K. So our H and K, remember it's going to be, this is our H and this is our K. It's opposite, so hips are opposite, so -4, and then knees are normal, -1. So this particular graph is going to start at -4, -1. That's our starting point. The second thing we have to find is our A. So our A value is what's in front of the square root sign. So A is 2. So remember, this is going to affect our stretch. We have a stretch now. So we're always using this pattern. So this is our pattern. Up 1 times 2, and then we go over 1, 3, 5. That's our pattern. Okay, so in this case, we're going to go up 1 times 2. So up 2 over 1, up 2 over 3, and up 2 over 5. Because it's always up 1 times A, whatever A is. In this case, the A is 2, so that 2 goes right there. Okay, so when we do this graph here, we're going to start at our starting point, so -4, 1. We're going to go up 2 units, and then to the right 1, up 2 units to the right 3, and up 2 units over 5. Okay, and then we're going to draw our smooth curve and make sure we have our arrows at the end. And that is going to be the graph. And it was much quicker than using a table. Now again, we're going to use our domain. So our domain is going to be x is greater than or equal to, and remember we're looking at our -4. Notice our graph starts at -4. That's our starting point right there. So x is greater than or equal to -4. And our range is going to be y is going to be greater than or equal to -1. And again, we can see it in the graph, but we can also look here at our starting point right here and notice that it corresponds to our x and y's here. Okay, and then just knowing if it's greater than or less than. If the only time it's going to be a less than sign is if there's a reflection, and that's only going to affect the range. The reflection does not reflect the domain. Okay, so let's try number 6 here. So we're going to have y equals 3 times the square root of x minus 1 plus 2. Again, make sure the plus 2 is outside of the square root button. So what I want you to do is I want you to try number 6. I want you to use the transformations, graph it, and then write the domain and range using whatever notation you prefer. And then whenever you're ready, turn the video back on. Okay, hopefully you're now ready to see the answer. So you should have your starting point at a positive 1, 2. Okay, so again, our starting point is right here. And then you should have gone up 3 over 1, up 3 over 3 units. And then that's as many points as we can get on the graph, on this particular graph. But if I could have, I would have gone up 3 over 5. You could keep doing this. It would be up 3 over 7, up 3 over 9. You keep going. But as long as you have at least 3 points, then you should be able to see a good curve. The domain is going to be x is greater than or equal to 1, and the range is going to be greater than or equal to 2. So if you got this one correct, if you'll give yourself a little smiley face down in the corner, if you got it wrong, give yourself a little frowny face, and then make sure you make corrections to your notes. Also, make sure you put an arrow on your graph. Remember, there's an arrow going to the right. Okay, in fact, for this particular graph, we will always have our arrows going to the right. And the reason being is because we don't have a reflection over the y-axis. We only have a reflection over the x-axis. All right, number 7. So y equals negative square root of x minus 3 plus 2. Oops. Sorry about that. Plus 2. So again, our starting point is our HK, which in this case is going to be positive 3 and positive 2. Remember, it's opposite hips. Now, this time our A is a negative 1, which means we have a reflection. Okay, so instead of going up 1 over 1, we're going to go down 1 over 1. Down 3 over, sorry, let's try that again. Down 1 over 3, and then down 1 over 5. And I would recommend writing this down because especially coming off of quadratics, it can be confusing on which one you're going down and which one's going the odd pattern. So in this case, the odd pattern is the over. Okay, so we're going to start at positive 3, 2. So 3, 2 right there. It's our starting point. We're going to go down 1 over 1 to the right, down 1 over 3 to the right, and I think that's as many points as I can get. So a nice curve, just like our parabolas have a nice curve, and a nice arrow on the end. And then our domain is going to be x is greater than or equal to 3, just like we can see in our starting point. Now, this time what's different is that our y is going to be less than or equal to 2. So notice that here our starting point still corresponds to this, but what's different is the fact that this negative exists right here affects my inequality sign, and it only affects it on the range. The y is less than or equal to 2. Okay, so let's try number 8. We're going to have y equals negative 1/2 times the square root of x minus 1 minus 2. So our starting point, once again, is going to be 1, negative 2. Our A equals negative 1/2, which means we have a reflection and a shrink. So we're going to go down 1/2 over 1, down 1/2 over 3, and down 1/2 over 5. Okay, so starting at 1, negative 2, which I believe is about right there. And then we're going to go down a half unit over 1, so we're going to be in the middle of lattice points. The down a half again over 3, and that creates a lattice point. And then down a half over 5, which can't quite get it on there, but it is going to look something like this. So it's not nearly as high up, it's a little more squished down. And then our domain is going to be x is greater than or equal to 1. Our x's are always greater than or equal to. And our range is going to be y is less than or equal to negative 2, because this time it has a reflection. Okay, so hopefully the transformations I think are a little bit easier to work with, especially when you have a lot of stuff going on. You can, of course, use a table, but it's not always easy to use a table unless you have a graphing calculator. All right, last thing we're going to do is we're going to describe the transformations from the parent function and give a domain and range without graphing. This really isn't too difficult. So number 9 is going to be y equals 4 times the square root. Sorry guys, my computer's being a little crazy. 4 times the square root of x minus 9. And that minus 9 is on the outside of the radical, so make sure the square root is only over the x. So first things first, let's look at our transformation. So if we start at the front here, we'll start with that 4. That is going to be a vertical stretch because it's more than 1. And we're going to have to make sure we say by a factor of 4. Remember, you need to use very specific language. So vertical stretch by a factor of 4. Okay, our next piece is this subtract 9, and this subtract 9 is going to move our graph down. So it is going to also be a vertical, but this time it's going to be a translation. So remember, we have stretch, shrink, we have reflection, and we have a translation. So vertical translation, 9 units down, or you can say down 9 units, however you want. But you do need to tell me the direction and the number of units. And those are the only 2 transformations. So now the last thing we're going to do is we're going to find the domain and range. So our domain is going to be x is greater than or equal to. And remember, it corresponds to our starting point. So this particular graph's starting point would be at 0, negative 9. And since it's starting at 0, negative 9, because there is no horizontal translation, x is going to be greater than or equal to 0. And then our range would be y is greater than or equal to, because there's no reflection, negative 9. Okay, so you still have to kind of think of your hips and knees. Where's this graph starting? It's starting at 0, negative 9. And that's how your domain and range is going to work. Okay, so number 10, y equals negative 3 times the square root of x. Okay, so the first thing we have here is we have this nice little reflection, because the negative is the reflection. So this is reflected over the x-axis. Okay, and then this 3 is separate. Okay, so you have to consider these as 2 separate things. So just the 3 and just the negative. Okay, so the 3 is going to be a stretch because the 3 is bigger than 1. Remember, it's the absolute value. You think of the negative as separate. So the negative is the reflection, the 3 is the stretch. So this is a vertical stretch by a factor of 3, not negative 3, 3, just the number. Okay, so now, again, we have to consider our domain and range. So our domain is going to be x is greater than or equal to, because that's always how it starts. Now, there is no h or k here, so since there's no h or k here, this particular graph is going to start at 0, 0. That's the starting point. So x is greater than or equal to 0. And then our range is going to be y is less than or equal to 0, because it's reflected. So the reflecting means that this graph is going to be going down, like so. Okay, which means there's going to be reflection, so the y's are going to be less than. All right, number 11, last one, and I want you to try this one. So it's going to have a little bit of everything in it. So y equals 1/5 times the square root of x plus 2, and then plus 3 is on the outside of that radical. So write down all the transformations in the domain and range, and when you're ready, turn the video back on. Alright, hopefully you're ready to now see the answer. So this particular function has a vertical shrink by a factor of 1/5. It has a horizontal translation left 2 units. Remember, the horizontal is opposite, so adding 2 really means minus 2 to the left. And then a vertical translation of up 3 units. The domain would be all real numbers greater than or equal to -2, and the range would be all real numbers greater than or equal to 3. So if you got this one correct, please give yourself a little smiley face down somewhere in that box. If you got it incorrect, give yourself a little frowny face and then make sure you correct it. Okay, you've now reached the end of the notes, so make sure you put this in the notes section of your notebook. And now you need to get and complete your homework.